So implicit, actually, well, I don't think, well, we might be able to write this explicitly. If you think about it, we'd have to take the square root of both sides, subtract sine pi x from both sides, and then take the arc cosine of both sides, which would be the arc cosine of the square root, the arc cosine of the square root of 2 minus sine pi x, and then we'd have to divide both sides by pi. I mean, wouldn't exactly be an easy thing to do. It would be a little more difficult, and we might as well just use our implicit differentiation. It's one of the tools we've got. So one of the things that I will continue to help you with is when you look at this notation, consider what information is given to you. The notation of mathematics is there as kind of like a GPS to the problem you're working with. What's the output variable we need? What's the output variable? Y, okay, because it's up here. Okay, so the output's y. What input variable do we need to have in our derivative? And everything has to be an x. Okay, we can't have it in u in terms of u. That's one of our chain rule ideas. So if we're going to look at this and look at the implicit differentiation of this, it means we're going to take the derivative with respect to x of the sine of pi x plus the cosine of pi y, that quantity squared, equals, and you know the old rule from Algebra 1, what you do to one side of the equation, you must always do to the other. So we're going to take the derivative of this side. This becomes rather easy, doesn't it? Just 0 on that right-hand side. This side's a little more complicated. We've got, first of all, do you recognize a composite function? Can you see, if you look at this, just this left side, do you see a composite function?
Yes.
Okay, what would be the outside function?
X squared.
Yeah, squaring something. Okay, and that something happens to be pretty complicated. So the first thing we do here is take the derivative of the outside function, so it would be 2 times the sine of pi x plus the cosine of pi y, and that's going to be to the first power is equal to 0. Now once I have the composite, well, I think I just made a huge mistake. I should ask you what I made a mistake on. What did I forget to do? Yeah? The inside function. So we're going to take the derivative with respect to x of sine pi x plus cosine pi y, now we can say is equal to 0. Okay, so the derivative of the outside function, if you need to, always give yourself that little hint. This is the derivative of the outside, and this is showing that we're going to take the derivative of the inside. Okay, so we've got 2 times, and we'll just report this back. Nothing really to do with this at this point. And our derivative of this quantity here. The derivative with respect to x of sine pi x. Within this, and I'm going to actually break this down for you. I want to make sure we understand that we're taking the derivative with respect to x of both of these. Because now within this derivative with respect to x of sine pi x, do you see another composite function? So Meep, you were saying yes. What's the inside function? Pi times x, and the outside then is sine. Okay, so we've got 2 sine pi x plus the cosine of pi y times, and so now we would do the outside. What's the derivative of sine? Cosine. Again, that's one of those that I expect you to know. Okay, times the derivative with respect to x of what? Pi x. plus, do we see a composite function here? Same type, right? Outside is cosine, inside is pi y. So now I need the derivative of cosine. Again, Hannah? Negative, yep, negative sine of what? Pi y, okay. And now the derivative, and this is where, this is the first time where the chain rule is going to come in, because now we're taking the derivative with respect to what? X. And what we have in here is no x, it is a y. Okay? So I said chain rule. We're actually using the chain rule, but we're also using the composite, or excuse me, implicit rule here. Okay, equals 0. There we go. 2 sine pi x plus cosine pi y. There we go. And inside here we have cosine pi x. I'm going to put that in parentheses because to that whole quantity I'm going to multiply what? Yeah, because the coefficient's pi, and so the derivative of pi x is pi. I'm going to make this now minus because of adding a negative, so minus sine pi y. And to what do I multiply that? Well, my coefficient is pi, right? And then I must take the derivative of what? I don't have an x. The derivative of what? Y with respect to what? I'm sorry, what? What are we taking the derivative in each of these cases with respect to what? X. So it's pi times the derivative of y with respect to x. What are we trying to solve for? Where are we going? dy dx, yeah. Now if I didn't have dy dx there, could I solve for dy dx? If I don't have this here, Amber? If I, without that, I don't have a problem, okay? So, yeah, and again, we're taking this with respect to x, and y is not x. We're taking the derivative of y. Do you notice what we've done on each of these? Notice what I've done. I've done the derivative of pi x with respect to x. The derivative of pi y with respect, what does pi y and pi x represent? We said that they were composite functions, right? So pi x as a composite function is the what of the inside function? Not the input. That's the output, yeah. If we say u equals g of x, we would say this is pi x. What's the input of the inside function? X. What's the output? Pi x. And so each time I have you write this out, you're doing the same thing you end up doing down here. You're taking the derivative of the output with respect to the input each time. I don't know if you realize that or not. Math is really, I say this and I know how it can be translated in some students' minds, but math is really very simple if you understand the knowledge, or excuse me, the language of mathematics. But isn't that true of everything? French is easy if you understand the language. Chemistry is easy if you understand the language. Math is the same way. So we just have to go back, and this is why I keep harping on input-output. Sine pi x is the output of the function sine pi x, or maybe f of x equals sine pi x or whatever. Okay, let's go on. So I've got 2 sine pi x plus cosine pi y. I then have, I'm going to make it pi cosine pi x, so I don't get confused with what value or what that represents. Minus, I'm going to say pi dy dx of of sine pi y. Now, to make this even probably clearer yet, it would be helpful if we maybe put parentheses around this, or we could put parentheses here to help you understand that, you know, this is another function. I'm going to solve for dy dx. Do I really need to go through all the algebra of this with you? You did this actually back in elementary grade. You started the idea of solving for the unknown. Remember those problems? You'd have 2 plus whatever's here to be 3. The teacher would say, what goes here? You might have added on, but some people in their minds might have then started to say, well, that's 3 minus 2. So you start back in elementary grades. Things just get a little more complicated as we move up in the grades here. But we're doing the same thing. So, oh goodness, what's going to happen to this factor in my first step of simplifying, solving for dy dx? I've got how many factors here? Can you see them? I'll put them in green today. There's one factor, right? What's the other factor? This is multiplied to what? The whole rest of it. Yeah, everything inside. This is why when you forget to put in parentheses or brackets or equal signs, you really are not giving yourself enough help. So now that I see I have 2 factors, what's going to happen to this factor? What's the algebraic step? Divide by. Divide both sides by this. Well, what's going to happen to it when I divide 0 by that? It's just going to be 0. So I actually end up with pi cosine pi x minus pi, and I'm going to do it this way this time, sine pi y dy dx equals 0. Now, if you need to go back on this problem, you need that little help. Because, you know, 2 hours later, you're going to go back and say, what did she do with that? You might just say divided by, you know, you might want to actually put it down here and show that you divide both sides by that. It's going to become 0 when you divide it into 0. Okay, so are you finding your way? Do you see how we're going to do this? I got negative pi sine pi y dy dx equals negative pi cosine pi x dy dx has a value of cosine pi x divided by sine pi y. And never lose sight, what does this tell us? This yields. It will allow us to find what? It's a derivative. What's it allow us to find? The slope of a line tangent to what curve? This one at a point. Now, when you look for a tangent to a line, or excuse me, tangent to the curve at a point, what information do you need now in order to find that tangent, the slope of that tangent? And of the point, you need both x and y of that, okay? Because you have an x here and you have a y here. Okay. Let's go on. I'm going to
change pi to x. Like up top you have pi cosine pi x, and then when you subtract the other side.
okay, let me go. At this line,
One down.
this one?
Yeah.
Okay, so
You should just have a pi instead of cosine instead of an x. Yes, right there.
right there? Okay, thank you. Thank you. You're absolutely right. Did anything else I need to change? Yeah, I know.